Hello dear students, in this video I'll continue with the 7th unit Financial Mathematics. In this video we will see some more amortization formula and we will solve a problem where we have to find the principal outstanding at the beginning of kth period. In my previous video I have explained what is EMI, then how we can calculate EMI using flat rate system and using reducing balance method. Now under reducing balance method, we saw a few amortization formula. Now we will continue with some more amortization formulas. In the previous video, we have seen the formula for the periodic payment or installment EMI. It is given by R is equal to P upon A at an angle N for I rate per period. Now this A at an angle N for I rate per period, it is nothing but it is the present value annuity factor. It is given by 1 minus 1 plus I the whole raised to minus N upon I, where here P is the amount of loan, then I is the rate per period and N is the number of equal payments. So in the question all these will be given, we have to find EMI R. Now let us write this as this is equal to P into I upon 1 minus 1 plus I the whole raised to minus N. So usually in the sample paper the value for this expression 1 plus I the whole raised to minus N will be given. Then we have to substitute the value of P, I and the value for this expression and find EMI. So that is with respect to the formula for EMI. And then the next formula is finding the principal outstanding at the beginning of kth period. So the principal outstanding at the beginning of kth period, it is given by EMI R into A at an angle of N minus K plus 1 for I rate per period. So at A at an angle N for I rate per period, this is the formula. Here for finding the principal outstanding at the beginning of the kth period, we have to use this formula. So here A at an angle N minus K plus 1 for I rate per period, it is nothing but 1 minus 1 plus I the whole raised to minus N plus K minus 1 upon I. So this is calculated as R into 1 minus 1 plus I the whole raised to minus N plus K minus 1 upon I. So this is the formula to calculate the principal outstanding at the beginning of kth period. Next we have the interest paid in the kth payment. It is given by R into I into A at an angle of N minus K plus 1 for I rate per period. So this if we simplify we get it as R into I into A at an angle of N minus K plus 1 for I rate per period. Here in place of N we are substituting this value. So we are getting this formula. So that if we substitute here we get 1 minus 1 plus I the whole raised to minus N plus K minus 1 upon I. So this I and this I will get cancelled. So the formula is R into 1 minus 1 plus I the whole raised to minus N plus K minus 1. So this is the formula to find the interest paid in the kth payment. And next we have the principal paid in the kth payment. So if we calculate this EMI consists of principal and the interest. So the interest that is paid in this kth payment, we can use this formula to find. The principal paid can be calculated using the difference between the EMI and the interest paid. So principal paid in this kth payment, it is given by EMI minus interest paid in the kth period. So using this formula, we can find the principal amount which is contained in this kth payment. And next we have the total interest paid. Again this formula also we have seen in the previous video itself. It is nothing but N into R minus P. So if we take N into R, R is the size of each payment or the size of each EMI. If we take N into R, it will give the total payment that a person makes for a particular loan. It will consist of both the interest and the principal. If we reduce the principal from this value, we will get the total interest paid. Now let us solve a problem where we have to use all these formulae. This problem I have taken from Applied Mathematics by M.L. Agarwal. A loan of rupees 4 lakh at interest rate of 6.75% per annum, compounded monthly, is to be amortized by equal payments at the end of each month for 10 years. Find the size of each monthly payment, the principal outstanding at the beginning of 61st month, the interest paid in 61st payment, the principal contained in 61st payment, and the total interest paid. So we have seen formula for all these. So let us recall those formula and let us find the answer for each of these questions. It is given a loan of rupees 4 lakh. It is taken. So this is the principal amount P. This is P. At an interest rate of 6.75% per annum compounded monthly. So I will be 6.75% divided by 12 since it is compounded monthly by equal payments at the end of each month for 10 years. So N will be this 10 into 12. It will be 120. So using all those values, we can find the answer for each of these. So first we have P as rupees 4 lakhs. Then I is 6.75% upon 12. It is 0.00675 upon 12. It is 0.005625. And next we have N. N is 10 into 12, the number of payments. 120. And now let us find the first one. The size of each monthly payment. The size of each monthly payment, it is nothing but it is the EMI. So the EMI is calculated as R is equal to P upon A at an angle N for I rate per period. So it is P into I upon 1 minus 1 plus I the whole raised to minus N. So here P is 4 lakhs. Into I is 0.005625 upon 1 minus 1 plus 0.005625 the whole raised to minus 120. N is 120. So here 4 lakhs into 0.005625, it is 2250 upon 1 minus, this is 1.005625 the whole raised to minus 120. 1.005625 whole raised to minus 120. So it is 2250 upon 1 minus. The value for this is given as 0.5101. 0.5101. So it is 2250 upon 0.4899. Now this when we divide, we get it as 4592.77. Our EMI is approximately equal to rupees 4593. So this is the EMI. So we are using the formula for EMI. We have the value for P, it is given, I is given, N is given, and the value for this expression 1 plus 0.005625 the whole raised to minus 120, that is also given. Substituting all these, we get the value. Next we have the principal outstanding at the beginning of 61st month. So the principal outstanding at the beginning of 61st month, it is nothing but it is R into A at an angle of N minus K plus 1 for I rate per period, or it is R into 1 minus 1 plus I the whole raised to minus N plus K minus 1 upon I. Here N is 120, K is 61. That if we substitute, we can find the answer. R is, we just now got R as 4593 into 1 minus 1 plus 0.005625 the whole raised to minus 120 plus k is 61 minus 1 upon 0.005625. So this is equal to 4593 into 1 minus 1.005625 the whole raised to, here we have minus 120 plus 60. So it is whole raised to minus 60 upon 0.005625. So the value for this expression is given here. 1.005625 the whole raised to minus 60 is 0.71423. So it is 4593 into 1 minus 0.71423 upon 0.005625. So it is 4593 into 0.28577 upon 0.005625. It is 4593 into 50.803. So this, when we simplify, we get it as 2,33,338. So the answer is principal outstanding at the beginning of /61st month equal to rupees 2,33,338. So this is the principal outstanding at the beginning of 31st month. Let us continue with the remaining subdivisions. So the size of each monthly payment, we got it as rupees 4593, and then the principal outstanding at the beginning of 61st month, we got it as rupees 2,33,338. The third subdivision is the interest paid in 61st payment. The interest paid in 61st payment, the formula is R into I into A at an angle of n minus k plus 1 for I rate per period. So it is R into I into 1 minus 1 plus I the whole raised to minus n plus k minus 1 upon I. So this I and this I will get cancelled. So the interest paid in 61st payment we can calculate using this formula. R is 4593. We just now calculated R into 1 minus 1 plus I is we calculated as 0.005625 the whole raised to minus n is 120 plus k is 61 minus 1. So this is 4593 into 1 minus 1.005625 whole raised to minus 120 plus 60. So whole raised to minus 60. So this is 4593 into 1 minus, the value for this expression is given here, it is 0.71423, 0.71423. So it is 4593 into 0.28577. So this, when we simplify, we get it as 1312.5. So this is the interest paid in the 61st payment. And the next subdivision is the principal contained in the 61st payment. So the EMI for the 61st payment. For each payment, the EMI is going to remain constant. So this is the EMI. EMI for the 61st payment is 4,593. The interest in the 61st payment is 1,112.5. So if we subtract these two, if we find the difference, we will find the principal contained in 61st payment. So the principal contained in 61st payment will be EMI minus interest paid in 61st payment. So it is 4,593 minus the interest paid in 61st payment, 1,312.5. So it is 3,280.5. So this is the principal contained in 61st payment. And finally, we have the last subdivision, total interest paid. Total interest paid, we know it is N into R minus P. N is 120, R is 4,593 minus P is 4 lakhs. So this is P. So this is 5,51,160 minus 4 lakhs. So it is 1,51,160. So this much is the total interest paid. So if we remember the various formulae, we can find the answer for each of these subdivisions. I hope this video was useful for you. In my next video, I'll start with the next topic in financial mathematics, which is nominal and effective rate. If you have not subscribed to my channel, please subscribe. Thank you for watching.